Alright, chapter 12. We're doing circles now. Just a little note, there's going to be a lot of Pythagorean theorem in these problems and a lot of right triangle kind of things. So you need to make sure that you understand what those things are. Alright, so here we go. We start with tangent lines. So a tangent line is just a line that touches a circle in one point, and that one point is called the point of tangency. Just It only intersects the circle once. If it intersects the circle more than once, then it has a different name. So, first theorem in this, if a line is tangent to a circle, then the line is perpendicular to the radius drawn at the point of tangency. So, AB out here is my tangent line. P is my point of tangency. So this radius in here, OP, is perpendicular to AB. So that's why there's a right angle in here. And you can already see there's right triangles coming in here and in here. There's going to be a lot of Pythagorean theorem in these problems. Alright, so let's try one. It says ML and MN are tangent to circle O. So if ML is tangent, that means this is a right angle. And if MN is tangent, then this is a right angle. And we know for a shape like this that has four sides, it adds up to 360 degrees total. So if we take this shape and we add it all up and we subtract from 360, we get 63 degrees for x. Okay, so you take 360 minus 117 minus 90 minus another 90 and get 63 as your answer. Alright, for this one it says ED is tangent to circle O. Find the value of x. So if ED is tangent, that means there's a right angle right here. And we know that triangles add up to 180. So if you take 180 minus 90 minus 38, you get 52 degrees. Alright, classic problem. It says a dirt bike chain fits tightly around two gears. A chain goes around the outside here. And the chain has to fit tight. If it's too loose, then you're going to slip gears. If it's too tight, then it's going to snap. So you can't have too much. Alright, so we need to know this orange line, the distance between the centers of the gears. So picture this. I can create a right triangle here using the 26.5. So this piece right here is 26.5. It's just like I moved it down and created this right triangle down here. Alright, this whole side on the right is 9.3, but this side is 2.4. So I need to know what this is. So we take 9.3 minus 2.4 and get 6.9 inches right here. Okay, so now I need to know the length of that orange line. And if you remember your right triangles, you realize that's the hypotenuse. So we're going to do 6.9 squared plus 26.5 squared equals c squared. So work your Pythagorean theorem. And you get 27.4 inches. And that's the distance, the orange distance between the two gears to make sure that the dirt bike chain fits just right. Okay, a little trickier of a problem. So let's go try another one. Same deal. A belt fits tightly around two circular pulleys. So there's a belt running around these pulleys. We want the distance between the center of those pulleys. Okay, so do the same thing. Take this piece, move it up, create a right triangle here. Okay, so this used to be 14 here. This part is 8, so that means this part has to be 6. And we created a right triangle in the top here. So we're still finding the hypotenuse, it's just upside down this time. So we'll do 6 squared plus 35 squared equals c squared. work your Pythagorean theorem. You get 35.5 inches between the two pulleys. Alright? If you have questions, you need to ask. Alright, theorem number 2 in this chapter. If a line in the plane of a circle is perpendicular to a radius, then the line is tangent to the circle. So this actually is a converse of 12:1. Okay? So it's saying that if they give you a line with a circle and it's perpendicular to a radius from a circle, then that line has to be a tangent line. The best way to figure this out is they're going to give you something where you can draw a right triangle, and you prove to me that it's a right triangle by doing Pythagorean theorem. Okay, so the question being, is ML tangent to circle N at L? So this is L, this is N, this is N. And it wants to know, is it tangent to that circle? So I need to know right here if there's a right angle. So we need to try a Pythagorean theorem and see if it works. So I want to know, does this work? Okay, so type this in a calculator. 7 squared plus 24 squared. We get 625. And 25 squared is 625. And those are equal. So yes, it is tangent because this is a right triangle. So this right here is a right angle because of Pythagorean theorem. Alright, two definitions that we need to have. Inscribed in means that there's a circle drawn inside the triangle, and that means that each side of the triangle is tangent to the circle. So it touches the circle in one point. And there's another definition called circumscribed about, and this would be a circle drawn around the outside. We did this before when we did our constructions. I had you draw a circle that touched all three vertices of the triangle. So that's a circumscribed circle. This one is an inscribed circle. Alright, third theorem. Two segments tangent to a circle from a point outside the circle are congruent. So point B out here, there's a line from point B to A and from point B to C, and A and C are both points of tangency. So these are both tangent lines. Then that means that these two pieces outside the circle are congruent. Alright, so a classic problem that comes out of this. Circle O is inscribed in triangle ABC, and I want the perimeter of ABC. So from that theorem before, if we look over here at point B, because that looks just like our theorem, if this piece up here is 15, that means this one is also 15. Down here, if this piece is 8, this piece has to be 8. Up here, if this piece is 10, this piece is 10. And then to find perimeter, we add up all the sides. So we start in adding up all the sides, and we get 66 centimeters. Okay? So if you have any questions or you need to come in and see me, you need to get this under control. We don't have a whole lot of time left in this semester.